All right. The fact for the day, the word democracy is banned in online chat rooms in China. Very interesting. I don't know that that's true. Just in case you're a Chinese spying on me right now. I didn't make this slide, but I wouldn't be too surprised. I do know they have a lot more control on their internet in China than we do. We have a pretty free open internet here in the United States. Like that has good parts and bad parts to it, but they definitely control a lot more over there. I know for a long time they couldn't have an agreement with Apple because they were, and Google, because there was arguments over how much control they wanted as a country to be able to control systems and stuff. So, all right. So let's get to, oh, wait a minute. Note, assessment is not on Friday. It says on Friday. That's when it was like last year. This assessment is tomorrow. This is it. We are testing tomorrow. And this, number one, is a typical divide and conquer kind of question. But, and spoiler alert, it won't work. So divide and conquer doesn't always work because it's just because it's got 4 parts. It's a good clue that it might work, but I'll save you some time. It doesn't. So if I'm supposed to factor this and it doesn't just like factor, what can you use on this test that we didn't allow a couple of years ago? A calculator. Everybody grab your graphing calculator. I'll pause for a second while you do that, right? So do you get that there's a calculator way to find the possible roots? You just graph it. Has anybody already got it graphed? Did it touch the x-axis? If it touches, then that's a root. And I know what the root is, and I know, therefore, what I could use in synthetic. So where did it touch? Was it a nice number? Because if it was like 1.635, it's not going to work. Anybody tell me? Okay, so let's say that it's going through, and you don't know how to tell where it's going through. If the graph did that, did it touch? Yeah, it touched right there. How come I can't? What if I don't know what that spot is? You do second calculate the 0, and then you make the little spider. This little spider thing pops up, and you go to the left of it, and then to the right of it, and then right on top of it. You hit enter, 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 and then it finds you the 0. Would somebody please find exactly where this thing touched? Yes, sir? Was -2? Awesome. Then -2 is, uh-oh. Okay, a lot of people are disagreeing. What did you get?
I got -1.65.
-1.65, okay. You can't just assume it was at 2. Maybe you had typed in a number wrong and it happened to actually work, but yeah, you better make sure, because if it's like this, that's not going to work. You can't put -1.65 into that box. You know what I'm saying? And you're doing synthetic, and then not going to work. Okay, so what happens if you graph it and you get a decimal? Well, at least you know it has a root. But this is a typical case where you'd be asked to write out the factors of the constant f-con over the factors of your coefficient. Very good. You learned something apparently that day. I think in your class, I think I taught it Thursday, right? And then you guys had Friday to practice, do homework. Okay. So f-con over f-co. So what are the factors of the constant? 8 and 2 makes 16. What else? And 4 and 16 and 1. You don't have to list them in any particular order. It's nice to the math teacher if you list them in order from smallest to biggest, but it's not required. All over the factors of the coefficient, which the coefficient is just a 1. So what's the factors of that? 1. So do I really need to divide everything by 1? No. If this had been like a 2 in front, then I'd have to put a 2 and I would need to divide it. But if it's dividing by 1, it's not really doing anything. And then what's the last step that so many people forget? Plus and minus. Good. So it's plus and minus of all that. You could even do that. That looks like plus plus. Let me try that again. Plus and minus of all that. So plus and minus 2, plus and minus 8, plus and minus 4, plus and minus 16, and plus and minus 1. Okay. So the moral of the story is this is only good to tell you what things could possibly be whole number roots of this. And it would have taken you forever to check every single one of those and find out that none of them actually worked. That can be the right answer. None of those factors that could have been, the possible factors, it's not a promise that one of them is going to work. It's just a promise that if any whole number is going to work, those are the ones that would work. All right, so would you do the same exact thing for this next problem, number 2? Find me f-con over f-co, factors of the constant or factors of the coefficient. And then you'll know what possible number I could put into synthetic right there. If it comes up, it'll come up with a nice little list for you. And of course, the calculator can help too, but don't rely on only the calculator. Number 1, you would not have known what that list was. That's what you'll have to do on the test. You can't just use your calculator. You have to know f-con over f-co to provide the list of what were the possible factors. Okay, Mr. V, tell me what you're doing to solve this thing. Okay, so what's factors of constant? I think that's it, right? And then factors of the coefficient? No. Oh, wait a minute. Is that the coefficient? No, that's not the coefficient. The coefficient is the one that's on the biggest power. That's the biggest power, so it's that guy. It's the factors of that guy. Yep, 3 and 1. Now, everything has to get divided by 3, and everything has to get divided by 1. So, one thing at a time. 9 divided by 3, 3. 3 divided by 3, 1. 1 divided by 3, 1/3. And now I got to divide everything by 1. 9 divided by 1, 9. 3 divided by 1, 3, and 1 divided by 1 is 1. There's my list. Was there any redundancy in there? The 3 and 3 and the 1 and the 1 are kind of like repeats. Okay, so we don't need 2 3s and we don't need 2 1s. So my final answer, true or false, is 1, 3, 1/3, and 9. False, because I forgot one thing, plus and minus. Plus and minus of all of those. Those would be the possible roots of this. In the old days, a couple of years ago, we had everybody check every single one of those with synthetic. You have to stick in a 1 in synthetic and then see, does it work? How do you tell if it worked? Ends with a 0. Good. But we don't have to do that anymore. We can just use a calculator. Everybody grab the graphing calculator. Type this puppy in there. I know it's long, but it shouldn't take you that long. Type that puppy in there and tell me where it touches. That was a nice number. If it only touches at a weird decimal, what does that tell you? It's not going to work for synthetic. All right. For long division, it would be able to still be factored with long. Yes. But we wouldn't, only if we gave you the factor. So if we said, for instance, do this with long division, but we'd have to tell you what goes in. Like we'd have to say, does x squared plus 1 go into that with long division? And then you'd go, okay, I'll check. Long division goes like this. And then you see, okay, I got to check and see if it works. And you got to go all the way to the end and see if there's a remainder or not. Real pain in the butt. But that is a possible question, yes. But I wouldn't have expected you to come up with x squared plus 1 as the possible factor. All right. So all you would be expected to know on problem number 2 is these answers, which we already got. They're green right there. How many of you got those right? Okay, good. Let's move on to the next kind you'd actually have to do. Look at how insanely huge that is. You are in a high-level math class when you're asked to factor something like that. Because honestly, they don't even factor stuff like that in our AP calculus classes. But you could. Notice, little thought bubble, you will be allowed to use a calculator. What do you think that's a hint of? You probably should use the calculator. And let's say it comes up with, like, it touches at 7. This is what you use, synthetic. If every time, I'd want to use synthetic for everything I could. We will do one long division problem for practice, but long division is slower and clunkier. There's a few people that actually have told me they like it better, and that's cool. You can do long division every time if you want. Probably be good for you to practice putting one of these in there. So if you haven't already, get that thing in there. And whoever's got it first, if you could find, I think this one's going to touch at a nice spot. Where'd you find it touching? Can anybody verify that? I usually don't believe the first person that tells me. Did you just cross at -9 too, or not? Ah, okay. Double check your equation. Maybe you typed in one number slightly wrong. That's all it would take. What'd you get? That's a good question. You can use either one. If it touches at 2 spots and they're both like nice whole numbers, or integers, I should say, because they can be negative whole numbers, either one would work. That's a really good question. All right. I'm hearing that -4 works. Can anybody verify that? Quite a few people. Okay, good. If you graph this right, it should have touched at -4. So that means -4 goes right here. Everybody try synthetic now. This is a nice one because there's no missing what? No missing terms. Like x to the second is missing. You know, like some of them don't have an x to the second term. You have to put a 0 in to hold place, you know, for placeholders. So anyway, there's no missing terms on this one, so it should be nice and easy. Yes, it's big, but it's not super hard. It's going to work. We know it's going to work because we saw that that's a root on the graph. All right, I'm going to pause while you give that one a shot. Okay, I'm going to start this thing and see if you remembered how to do it. The beginning is weird, different than all the others. You just drop it like it's hot. Multiply, add, multiply, add, multiply, add, multiply, add, multiply, positive 24. Sweet, it came out with a 0. I know it worked. Now, here's the key. Do you get what that really means? This is x plus 4 times all this. Let me erase a little of this extraneous stuff here. There's an x here, an x squared here, an x to the third here, and an x to the fourth there. Plus I need a plus in there and a plus in there. And now I got it. There, it's factored. But is it factored all the way? No. Now here's the thing that somebody else asked me before. Do you remember somebody saying, what if it touches at 2 spots? Did this one touch at 2 spots? Oh, it touched at positive 4 also. No. Oh, it touched at 4 spots. Okay, awesome. It touched at 5 spots. All right, now here's what's cool. We just grabbed one of the numbers, which was -4. Okay? Do you get that if -4 worked, I knew x plus 4 was going to be one of my factors right from the beginning? Tell me something else that you know worked. If -1 works, what's the factor for that? X plus 1. And what else was a root? So then there has to be an x plus 3. And what else? -2 touched. So therefore x plus 2. Do you get what I'm doing here? She's telling me all the answers. This is awesome. I'm able to factor it all the way. Okay, now if only one of those things had worked, then I'd do synthetic again. So I'm just going to say, imagine for a moment that all you had was the info that -2 was the other place it touched. Everybody, please, right now, just practice your synthetic by saying, well, if -2 touches then use synthetic on this equation. Just like we did it on this equation, now you can do synthetic on this equation with a -2. Try it. Rows 1 and 2, please compare. Rows 3 and 4, compare across. Rows 5 and 6, compare across. Okay, you should have put in a 1 and a 5 and a 5 and a -5 and a -6. And then, did it work? Cool. Drop it like it's hot. Multiply, add, multiply, add, multiply, add, multiply. I know if it hadn't worked, do you get that that just means I probably screwed up? You know what I mean? Because if you graph it and it's got that number, you know that number's supposed to work. All it would take is for me to go by accident, -3 times -2 makes makes -6, and I'd be like, wait a minute, it's not working. But you know it has to work, so you'd be able to go back and find your mistake. All right, so now, what does this mean? Well, we still have this. Does this need to be in our answer anymore, or is that like too old? That needs to be in your answer. And this needs to be in your answer as a what? X plus 2. Very good. So our final answer is an x plus 4, and it has an x plus 2, and it has all this. And this is x's, x squareds, and x to the thirds. Do you think it's possible that could be factored again? Yes, and that's the kind of questions you have on this test. They're not all like that, but there's probably 2 or 3 of them that are that long. You factored it, and I factored it again, and then I could factor it by grouping. All right, so if you can't handle it now, what makes you think you can handle it tomorrow? Factor that puppy by grouping. That 4-piece one right there, right here, that factors by grouping. Divide and conquer. Can factor that. The very first one, remember, you can use a calculator. It's not like it's cheating to use a calculator. So right now, if I wanted to, I wouldn't have to use divide and conquer. I could graph it again, see where it's still touching. Oh, looks like it's touching at 2. Then, one of your factors is 2. You could use synthetic. But I like factor by grouping, and I hope you do too. It's one of the easier ways. This part right here has an x squared in both parts. X plus 3 left. This part over here has a -1 in both parts. Very good. That way you'll have an x plus 3 left. Do you get if I didn't make it work so that they both had x plus 3s, that I couldn't continue? And therefore, what you did was smart. You factored out a -1. If you just factored out a plain old +1, it would have had a -x, like -3. And that would have not matched up nice. Okay, so now this is an x plus 3. And the leftovers is x squared minus 1. And I would have to mark it wrong, sadly, shed a few tears. The kid even remembered to bring down all these things because everybody else forgets that. But they still get it wrong because why? That last one can still be factored again. And that one would be an x plus 1 and an x minus 1. All right, here's one of the ones that all the time people forget. Say it's like this, x squared plus 1 and x plus 7. And they think they're factored all the way. It's not. This can be factored. X plus 7 is already factored all the way, but that can be factored. Stretch yourself. It involves an I. If you know it, write it. All right. In the back row, FD. What do you think? You got it. X and an X to make the X squared. Plus and a minus, because that's how this kind always works. And I would have agreed with an I, a 1i and a negative 1i, because that's the square root of 1. That would have been an okay thing to put in, a 1i and a negative 1i, but I like it the way you wrote it the best. So awesome. Do you get there's two answers then, I and negative I? Do you know what happens if people solve this without factoring it all the way? Imagine for a moment we didn't do that, and they left it this way. And when they solve it, everybody solves this and goes x squared plus 1 equals 0, x squared equals negative 1, square root x equals I. See how it's easy to forget the plus and minus? If you have them separated like we just did, do you see how you're probably going to remember to write that as two answers, I and negative I? All right. So last thing you can do is, if the original problem had an x to the third in it, look for 3 answers. If you only give me 2 answers, you know something's wrong, and you're probably missing one of the imaginaries. Another thing, way you can think of it is imaginaries are like deer. Okay, so you're driving down the road, all of a sudden a deer jumps out in front of you and runs across the road. Have you ever heard, have parents ever told you, oh, who knows what the next thing is they usually say? Maybe you don't know this. Deer usually are in sets of 2. Maybe you didn't know. If you have one deer run across the road, there's like a 75% chance that there's going to be another deer with it. Okay, how many of you have seen multiple deer go across the road together? Now you know what I'm talking. Okay, good, almost everybody. And so deer often are not alone. They are often, especially the females, they often run in groups, like little packs of like 2 or 3. So if you see one crossing the road, you don't just go, oh, I can fly down the road now because they already crossed the road. No, one crossed the road. And then its friend is probably coming right behind it. So it's really common for a person to see the first deer go across and they hit the second deer really hard because they thought, yay, I made it past the first. Ah! So anyway, imaginaries come in packs of 2 also. In fact, they always come in packs of 2. You will never, ever have an answer of just one imaginary number. Not on our, unless there's some weird way to do it, I don't know. So there's going to always be a plus and a minus version of the answer. So watch for the second imaginary. Okay, moving on, would you please find this slide? It's blue. And can you factor it by grouping? Nope. What's next on the list? Synthetic. Can you use a calculator? Yes, on the whole test you can use a calculator. So maybe that'd be smart. All right, pause for a second while I give this one a shot. Try to factor it all the way. And then you'd be forced to give the answers as, here's my imaginary answers, here's my real answers. That's kind of everything you have to know. Pause for a second while you give this one a shot. So, did you use a calculator and find that it touched somewhere? Did it touch more than one place? Ah, so then you get your choice. Give me some options. What were some of the places it touched? -2. Where else?
4.
+4. Okay. How many of you guys started with the -2? Raise your hand if you started with -2. Raise your hand if you started with the 4. That's about half and half. I'll do 4 just because it's freshest in my mind now. So I'm doing the 4. Now, if you did the 2, will yours come out exactly the same? No. When it's all done, if you do it twice, it will. But do you get that I'm factoring out some that I'm going to have an x minus 4 as my factor? And that's different than if I have an x plus 2 as my factor. They'll be different. But when you're all done, if you keep factoring, then the answers will be the same. Okay, so I'm going to start with that 4, and then I'll do it really kind of fast here. 1, -2, -7, -2, -8. Draw the line, drop it like a tot. 1, 4 is 4. Add them. Nope, +2. Almost messed up there. And then 2 times 4 is 8. Add them. Multiply them. Add them. Multiply them. Worked. Yay. Answer this. X minus 4. This. X squared, x to the third. Yay, I factored it. I can't just stop though, can I? So that's where you do it again. We know the other root. The other root was, what was it again? A 2 or a -2? -2? Okay, so then I go like this. And I go 1, 2, 1, 2. Draw the line, drop it like a tot, multiply, add, add. Oh, mistake? I don't think so. Okay. 1 times -2 is -2. And I should have just kept going. And if it ends with a 0, I probably did it right, right? Okay, so then Final answer. Oh, I'm going to show you a mistake that people make all the time. They say, okay, so my final answer is x plus 2, and that's x's, and this is x squareds, and so x plus 2 and x squared plus 1. There's two things wrong with that. What's one of them? Yes, sir. Yes, this thing we factored out doesn't just go away. X minus 4 has to be in your answer. And then that can be factored again. Very good. So this right there factors into x and plus and a minus and an I and an I. And technically it's got a square root of 1 in there. But that's 1. So 1i is the same as I. So there is the final answer. And then they would say, what are the real roots? And you would reply, what? 4 and negative 2. What are the imaginaries? Plus and minus I. Notice there's two of them. They travel in packs. Okay. All right. That's pretty much what you would need to know. Now there's tricky things like what happens if it's long division and you have an x squared plus 1. What's missing? X squared plus 1. Do you get, if you're doing long division and you have an x squared plus 1, there's something missing? What's missing? A 0x. You'd have to have a placeholder in that. All right, and I want to do one long division with you, so let's jump to your homework. And everybody pull that up, and I'm going to show you which one we can do long division on, just for practice. Okay? And everybody look at the worksheet. I'm going to pause. It's A, B, and C. We're going to do worksheet C as our homework. I had suggested to kids, if you want extra practice, if you know that, oh, I keep getting these wrong, I keep looking at the key and they're all wrong, then maybe you should do some extra practice. B would be another good option. A is a little too easy. But C is the one I'm assigning, and B is also pretty decent. So I'm going to pause for a second while I pull up C. All right, so here we are on worksheet C. And this very first one, if you can't factor that, I'm scared for you. That'll be a really easy one, right? That's like the easiest of them all. So let's move on to like number 2. Who can tell me the method that you use? Got a name? Divide and conquer. Factor by grouping, same thing. Good. Yeah, that's how you do this one. Should be easy for you. I don't think you need my help. Let's move on to number 3. That one confuses a lot of people, but it's super easy. We don't factor by grouping because they only do that with 4 parts. You don't have to do synthetic or anything weird like that. You can if you want to. What if you graphed it with a calculator? Could that tell you what to do with synthetic? Yeah, that would be a way. But there's the easy way. This is so easy. You just have to set it up as x squared, and x squared will make x to the 4th, right? And what are the other 2 numbers you'd have to put here and here? A 3 and a 2, because 3 times 2 makes 6, and it adds to 5. You're a genius. But is it positive 3 and negative 2, or negative 3 and positive 2, or 3 and negative 2, or what? Yes? Ooh, 6 and a 1 makes a 5. Oh my gosh. Which one is it? When you try it, you find out. Is it 6 and 1? Okay. 3 and 2 also makes a 5. I'm just saying. So anyway, we try it and we see if it works. So 6 and minus 1. Could that possibly be it? I'm going to double check. First, x squared times x squared makes x to the 4th. Yay. Outside and inside makes positive 5x squared. I'm on the right track. And then the last to make negative 6. Cool. That's it. Is it factored all the way? No. Notice, though, we didn't use anything weird for this. We just set up 2 parentheses and figured it out. You don't have to always use synthetic or long or divide and conquer or difference of squares, which is that x squared minus 16 kind of thing. But can you factor it all the way? There's 4 parts if you do this right. I'll challenge you to try this, and I'll remind you there's a square root as part of your answer. Everybody see if you can get factored all the way. Who's got it all the way? Only 5 people so far. Okay. To 6, 7. Anybody else picked it up now? 8, 9, we're up to about 10, 11, 12 people. Awesome. Okay, I'm going to do the easy part. X squared plus 1 is x plus 1, x minus 1. Yay, that was easy. The other part's harder. X and a plus and a minus is how you always start these. And because it's got a plus there, it has to use imaginary, so there has to be an I and an I. But do you get that I times I does not make 6? So it must have a 6 involved, or is it something like a 6? Square root of 6. There you go. If you had I root 6 and negative I root 6, you got it. Factored all the way. Because square root of 6 times the square root of 6 makes the square root of 36, which is 6. You can check by foiling it. Now, some kids last hour were saying, can't I just do this by saying x squared plus 6 equals 0 and solve it? Yes, you absolutely can. So I subtract 6, I got x squared equals negative 6. But those aren't a piece of cake to solve either. You got to do square roots and absolute values, and got to remember the plus and the minus. Do you see why I think this is a little easier if we just learn how to factor that way? Because then you don't have to solve this kind of stuff. Now, it's still good for you to know. I want you to know how to do it, but square root, absolute value of x equals I root 6, and then the absolute value breaks into 2 parts. X equals I root 6, and x equals negative I root 6. Yeah, I can still get my 2 imaginary answers that way. But it's just kind of cooler if you can factor it all the way. And you won't forget the plus and the minus. There's 4 answers. Should there have been 4 answers? Yep, because it's got a 4 right there. Are they all imaginaries? No. 2 are imaginary, 2 are real. All right, cool. Now, I did say we were going to try to do one long division. Now, I'm going to see if I can get through that here before our time runs out. So let's scroll to number 4. And I'm going to do that with long division. All right. In a situation, yes, sir? Okay. So in a situation like this, they would have said, okay, you're going to take the square root of 36x squared minus 49. Not square root of, sorry. That's the dividend going in the den. And then on the outside, we would tell you, all right, if they say you have to use long, then we would tell you that x minus 7 is a root of it. We'd tell you that part. Now, could you do long now? All right, so let's do this one. I know it's been a while since we've done long. The first thing is our problem is set up wrong. What's wrong? Placeholder. Yes, so instead of that just x squared minus 49, we move the minus 49 over, and we put in a what? 0x. Good. Has to be a placeholder for the x spots. Now we can do it. I would encourage you to do this with me. You need to know long, so might as well do it on this one. All right. Miss Q, can you tell me what to do? Where do I start now? Exactly. So that times the x has to make 36x squared. So what do you think that should be? 36x. I like it. Because 36x times x makes 36x squared. And then I make the 36 times the 7. Yuck. I don't like to do 36 times 7, but I'm going to have to do it. You'll have a calculator, though, right? So you'd be able to do this in a calculator. 6 times 7 is 42. 7 times 3 is 21. Plus 4 is 25. 257. Whew. So that's negative 257x. And I draw a line. Opposite, opposite. That's a 2 I just wrote sloppy. You're right. Sorry. You're right. Okay. And that's canceled. And that's positive 252x. Bring down the minus 49. Ick. But I'm almost done. What has to go here? 252. So 252, 252 goes right here. 252 times x is 252x. And 252 times negative 7. Oh, it's even worse. 7 times 2 is 14. 7 times 5 is 35. Plus 1 is 36. 7 times 2 is 14. 17. 1764. Holy smokes. And that's positive? No, that's negative 1764. Whew! I picked the worst problem in the world to do long division on. But that's the process. We're doing it right. Opposite, opposite. And now whatever negative 49 plus 1,764 is my leftovers. That means that x minus 7 was not a root. After all that, it had a remainder, so it didn't work. Okay, but anyway, I know that can be awful, but that's the kind of thing you have to be able to do for long division. All right, your homework is worksheet C and only worksheet C. Worksheet B is an optional extra practice, wouldn't hurt you kind of thing. The test is tomorrow. We've covered pretty much everything. If you want more help on that, you better stay after school because tomorrow morning is not one of the mornings you can come in and get extra help. So, all right, that's all I got for you for today.